Okay. Okay. So can you see the screen?
Yes, sir.
Yeah. Okay. So we'll start with the immunization because we want to talk about this particular
But we are
problem.
just seeing a white screen. We can't like see
Oh,
anything. We're seeing a white screen.
oh my God. Just a minute. Just a minute. Can you see now?
Yes, sir.
Okay. So what we are going to do is we are going to talk about immunization problem, and this is the most important uh, work in the area of bond portfolio management. The reason is why, because most of the investors in the bond domain or the bond market are retirees, pensioners, or those people who would want certain amount of money at the end of certain years, because they have certain planning. For example, providing for tuition fees to their children, buying a house, or going for vacation, or buying a car, or things like that. So for all the things you require planning somewhere in the future, and most people don't have enough money to make the down payment, and that's why this question bothers everyone, whether you will have enough money to sustain, especially when inflation is also a big problem nowadays, and it's a creating problem for everybody in the world. So what we are going to how we are going to see this problem is, normally people have expectation of like 30 lakhs, 40 lakhs, 50 lakhs, or 1 crore rupees for certain things. But we'll start with a very basic requirement of someone who needs uh, $1,790.85 at the end of 10 years. Okay, so someone wants $1,790.85 at the end of 10 years. So if 1,000 is invested today, 1,000 invested today, which is if you can see at where I'm pointing, and then this the interest rate is 6%. So you are compounding at 1.06, and if we raise it to power 10, because everything is going to accrue in 10 years. So ultimately, you are going to have going to end with this. So the simple problem of immunization is, if you want $1,790.85 and you are starting today with $1,000, so you'll end with it provided the interest rate is 6%. So this is the premise. Now the thing is, in the real market, the bonds available may not be exactly for 1,000. That's one problem. The interest rate may not be 6%, or coupon rate may not be 6%, and that's why this dilemma of which bond to use and when to use and how much to use, this always bothers. So what happens? We are starting with three bonds. Bond one. Uh, So we are starting with three bond one, bond two, and bond three. So let me give you a little brief about these three bonds, because these are the three bonds that we are going to use in almost all the examples here in after. So all the three bonds have $1,000 or 1,000 rupees as a face value, which is like almost a universal truth. So bonds normally have either 100 or $1,000 as face value. These three bonds have different coupons. So first bond has a coupon of 6.7%, second has 6.99%, and third has 5.90%. Why these three bonds have three different coupons? The answer is very easy. Bond one was just issued, means this is just issued bond. Bond two was issued 5 years ago, and bond 3 was issued 10 years ago, and that's why you can see that their time to maturity is different, because they were issued at different point of time, and they are going to have different prices because their coupons are different. As you know, bond prices are inversely proportional to the coupons. So this is the situation. Now we can calculate, just we are doing a little bit of warm up before we go and solve the immunization problem. So we can calculate the prices using NPV. But when we use NPV, we need to have something like this. We should have something like this where the cash flows are given, or like this where cash flows are given, and the settlement and maturity dates. So what we do is we use the PV function where it is easier. So we write PV, and then as you can see, it's asking for rate. So rate is nothing but the YTM. So we enter the 6%, and then number of period. So if I enter 30, so it takes 30 years. How much payment we are getting? So payment we are getting is $59 because it's $1,000 bond, and 5.9% is coupon. So 1,000 into 5.9 becomes 59, and then we enter face value, which is 1,000. And they no need to use type because type by default takes 0, which is US convention. And if I enter, so I get 986.24. So the price of this bond is 986.24 if this is how the bond is issued. If the bond is issued with 5.9% coupon for 30 years today, the price of this bond will be 986.24. Negative sign, you don't get carried away, because negative sign, what it means is you will have to pay. So if you pay 986, you will get coupon of $59 for next 30 years, and then finally the face value of 1,000 will be returned. Next thing that we can calculate is duration. So I talked in the previous class that the duration can be calculated in two ways. One is just the Excel duration, which is duration, and the other is our homemade formula, which is what we did using our Visual Basic application. So we did day duration. The advantage of day duration is this requires very little input and works wonder even if the payments are not very regular. So for example, if the next coupon is going to happen in 10 days, then also it can calculate duration. But in case of the Excel duration, the coupon payment should be evenly spaced. It means like every 1 year you should be getting next year, next year, next year. If there is uneven payment, the Excel duration will fail to give you the right duration measure. Now, what you need to remember for this day duration is there are 4 inputs required for day duration, and those 4 units are first in the order of input. The first is number of periods. So this first is 30 because this is going to be for 30 years. Next one is coupon in percentage. So we have written 5.9%. We'll keep it like this. Third one is YTM. And then the last one is alpha, which is like what is the duration of the first coupon payment, the time interval. So because we are assuming this as an even bond where every year we will be getting coupon payment, so we'll keep alpha as 1, and then we are done. And then this calculates our duration of 14.636, which is equal to 14.64. Now, the most important thing for these bonds are, as you can see, we started with $1,000 and we are investing at 6% so that we can get this 1790. So this 1790 we can get only when we start with $1,000 at current rate of interest. However, if you can see, the prices of these bonds are more than 1,000, and in case of bond 3, this is less than 1,000. So, but we want to buy 1,000 amount of bond, so we'll have to buy bonds with different face value. It means not one bond, but fractional bond, because we are doing it like an experiment. As you could see, when we did Black-Scholes, when we did the fraction share of the hedging, so we came with something like 0.45. So as you know, 0.45 shares cannot be sold or bought also. So you need to multiply by 10 and accordingly modify your portfolio. So that's exactly the situation we are facing. So what happens here is how much the face value we want to buy. So this is simple formula that we can use, though you can use the unitary method. So for example, if you pay 1005 105 1.52, you are going to get 1000 face value. So if you pay 1000, how much are you going to get? So it's very simple. So you have to multiply 1000 with this face value and divide by the price, whatever price is there, and then you get the face value. So we'll get 951 for this bond. Again, for second bond, we multiply because we want to buy 1000 rupees bond for 1000, and face value will be 1000, and we divide by the price which we are paying, and then if I enter, I get 912. So I will be buying face value of 912 in the second bond, first bond 951. In case of third bond, I will use $1,000 to buy, and I want to buy 1000 face value wala bond, but I will be paying this much money. So how much face value I will get? So I will get a different face value. So I will get the three face value for these three bonds, and then but how much I am spending? I am spending exactly 1000. I am investing 1000 rupees, but I am getting face bonds of face value this. So just remember this. These things I have done just like to make this spreadsheet look a little easier, so that we can calculate the future value and present value. Now, how these three bonds are going to solve the problem of immunization? So, as you know, we want 1790, which is what you can see it here. 1790.85 rupee dollar we want, because we are investing 1000 and we want 1.1790.85. So see what is happening. Now the let's calculate this the face value or the bond price. So what happens? Our horizon is 10 years. So in 10 years, the bond 3, let me write here. This is slightly involved, so just understand this concept. So this, because our horizon is 10 years, because we are investing 1000 and we are going to wait for 10 years so that we can get 1790.85. So if we are investing in bond 3, so we'll get the price of the bond. So price of the bond is going to be this rate 6%. Number of period is going to be 20, because earlier it was 30. Now we are immunizing after 10 years. We are going to see whether after 10 years, this bond will exactly give us what we need. So we are using this 20, and how much payment it's giving me. So it's because it's a bond 3. So as you can see over here, it's going to give you 59. So I will mention it minus 59 for simple reason. If I mention plus 59, it the value that will give a negative. So for the purpose of just this Excel, I want it negative. And then the next is face value. So again, I will write minus 1000, because this also will receive. So I'm taking this as and then what value I get, I will take that as I will be paying. So if I press enter, I get 988.53, exactly the price which is textbook is giving for this particular bond. So it means if I buy bond 3 and hold it for 10 years, 988.53 will be the price which I can sell it to some third party, because at the prevailing rate of interest of 6%, this bond is sellable for 988. Now if I want, but another thing is, I will have the coupon for the next 10 years. At the end of first year, I will get one coupon payment of 59. Another at the end of second year, I will get 59. Third year, so at the end of 10th year also, I will get 59. So I'm going to have the 9 coupon payments, which I will be investing. So what is going to happen? These coupons. So I need to calculate the face value of these coupons. So I write the formula face value. Now in this face value, what is going to happen is it's asking for rates, that at what rate your cash flows are going to be invested. So they are going to be invested at the current rate, which is what the current rate is prevailing. number of periods. Here what happens, because these are the coupons which are going to be invested for next 10 years, so I will keep it as 10 years. Okay. And then it's asking for payment. So how much I'm getting for bond 3? I'm getting 59. So if I keep it 59, so it takes 59, and then the next it is asking present value. What is the present value? So I don't have to pay anything for this. I just I'm starting with this. So I will keep present value as 0, and no need to keep type of the bond. And then if I press enter, I get minus 77, which is okay because I use the negative one. So here what happens if I sum these two numbers first, because second are negative, so I'm subtracting basically effectively. So I get 1766.20. So this is how I can get all the three bonds total value. Why? Because I am investing these three. I can invest in any of these three bonds, and if I invest in bond 1, I will get 1883. If I invest in bond 2, I will get 1962. If I invest in bond 3, I will get 1766.19698. Now remember, we have not invested entire money in these three bonds. As you can see, they like I have invested 951 face value, 912 face value in case of bond 2, and 1013 face value in case of bond 3. So accordingly, in terms of the proportion of face value bought, I will have to multiply whatever amount I am getting. So what happens? Let me just make it like this. So if here I multiply this, because this is the total amount that one can get, provided he has invested in the entire face value, but I have invested 95.1% of the face value. So I get 1790.847, and I just copy this, and I get the same amount for the bond 2 and 3. So effectively what is happening in case of these three bond 1, bond 2, and bond 3 is you are ending with the same value of 1790, which is what you wanted to have after 10 years. So basically absolutely no problem. Now the question that you should be asking, why is it at that you have three bonds, and all three bonds are three different prices, they're three different coupons, and their time horizons also different, like they have the tenors are different, but we are ending with the same amount. The answer is, the most important part is the YTM, because all these bonds are priced at the same YTM. Their pricing is happening at the same YTM of 6%, and that's why you don't have this issue. So the one line answer to our situation is, in case we have any bond we buy at a current YTM and our expectation rate of return expectation is the same, so irrespective of which bond you buy, you will end up with the same amount whatever you are anticipating. But the problem is when the YTM changes in the process. So now come to the real problem of immunization, because this was just a simple thing that you bought a bond and the YTM doesn't change after you bought the bond, and then you end up with the same amount of these three amount, which you can see. So you are not facing any problem. So yeah. Now suppose after you purchase the bond, the YTM changes to new value and the YTM stays there only. So for example, we are going to assume that the YTM changes to 5%, which is what this, if you can see over here in cell C205. Now we are assuming that the new YTM is 5%, changing to 5%. The previous one was 6%, and the next YTM is going to 5%. Just understand that there is a decline in interest rate, and that's why YTM is changing. Now the important question is how these three bond prices are going to bear. So these are the textbook prices, but we'll calculate bond 3 prices. So what happens is, in case of this bond 3 again we'll use the formula called PV, and it's asking for rate. So our new rate is changing to what? 5%, right? So we are changing it 5%. Then comma, and N per period. Now what is happening? This bond we are going to keep for 20 year. Why? Because we are seeing the horizon. This is a 30-year bond, and a 30-year bond we are pricing at the end of 10th year, because at the 10th year we'll receive the face whatever the price of the bond is, and whatever reinvestment coupon of 59 for bond 3, 69 for bond 2, and I think 67 for bond 1. This is how I think, yeah, 67 for bond 1, 69.9 for bond 2, and 59 for bond 3. So N per period, number of period, we are writing 20, because at the end of 20 means like at the end of 10 years, we'll have 20 years to price this bond. So we are writing 20. Just understand this difference. And then how much payment we are going to get? So payment we are going to get is, this is bond 3. So we are getting 59. If I write negative, then it will give me better answer. So let me write minus 59. And if I write face value as minus 1000, because ultimately this bond is having a face value of 1000. I leave everything blank. So I get 1112.16. Now what about the reinvested coupon? So again, the coupons will be reinvested. So there will be face value, this future value of the coupon. So rate is 5%. All the coupons will get invested 5%. They will get reinvested for 10 periods next, because we are going to receive it for the next 10 years. And then what is the payment that we are going to receive? So we are going to receive payment in this case of minus 59. Okay. And what is the present value we are seeing? So 0. And then I enter. So I get 744. And then here if I sum it up, then I get 1854. So this is how I get the 3 bonds price. Now if I multiply the 3 bonds price with the percent of the face value that we have invested. For example, in bond 1 we have invested 95%, 95.1 to be precise. In bond 2 we have invested 91.24% of the face value. In bond 3 we have invested 1.013% of the face value, because we invested this bond was priced at less than 1000, and that because we were investing 1000. So if you buy, if you pay 1000 for a bond which is priced at less than 1000, you are going to get more than one face value of the bond. Now, so here again, like this is nothing. So if I multiply this number into this number, I'm going to get this number. So as you can see, we are going to get 3 different results. So in case of bond 1, I'm going to get 1752.43. In case of bond 2, I'm going to get 1792.97. In case of bond 3, I'm going to end with 1880.14. Now, what is immunization? The first question that we should have started with is, what is immunization? So immunization is, irrespective of whether interest rate goes up or goes down, you're going to end with the same amount of money, come what. Interest rate goes to 10% or 5%, 12% or 3%, 20% or just 1%, you are going to end with the same amount of money. But that's not happening in these 3 cases. Case number 1, we are lacking miserably. Case number 2, we are just meeting our requirement of 1790.85. And case number 3, we are ending bond 3. If we are buying, we are ending with much more than what we needed. Now, why is this happening? The answer is duration. The answer is duration. If your duration is the same as your liability, so if the horizon of your liability is the same as your bond duration or bond portfolio duration, your bond is supposed to be immunized. So one of the important conditions for immunization is the duration of your bond should meet the duration of your liability, because your liability is going to be next 10 years. And as you can see, the duration of this bond, this particular bond, if I calculate, is 10 years anyway. It's calculated, but it should come to 10 years. So I'm going to use the duration. And then for the duration, I need the number of, so this bond was for, I think, 15 years. So this is 15. And then coupon for this bond was 6.99, I think. 6.99%. And then YTM in this particular case was 6% when it was issued. So 6%. And then I'm assuming that there is no alpha, means like it's a regular bond. And if I press enter, so this bond duration is coming at 9.994, which is exactly almost 10, means effectively 10. Whereas in case of this bond, the duration may not be 10. I'm sure in case of this bond, duration will be less than 10. I will tell you why this is less than 10. So again, this bond is for 10 years. So N will be 10. Coupon for this bond, I think bond number 1 was 6.7. Yeah. So 6.7% coupon. The next thing that comes is YTM. So YTM was 6% in this case of this bond. So, and again, there is no alpha, is there is no fractional alpha, it is yearly, it is evenly spaced bond. So as you can see, the duration of this bond is 7.67%. What about the duration of bond 3? So let me calculate duration of the bond 3. So this is 30-year bond. This is giving you coupon of 5.9%. The YTM when it was issued was 6%. We invested in this coupon, and then the fractional part is nothing. It's a evenly spaced bond, and then as you can see, it's a 14.63. So this is longer duration. So one takeaway from this particular example is, if interest rates are going to decrease, so bond price will increase. So you are advised to be in longer duration, or at least of the same duration as you are. So because bond 3 had longer duration, that's why the price effect for this bond was higher, and bond 1 was for lower duration. So price effect for this bond is lower, and that's why you are having a deficit in case of bond 1, surplus in case of bond 3, because the duration of the bond 3 is higher. In case of bond 2, you are exactly ending with the whatever the amount, 1790.85, which is what you wanted when you calculated this amount, 1790.85, because you wanted $1790.85 at the end of 10 years by investing 1,000 at current rate of interest of 6%. And that's exactly what is happening when you are investing in bond 2. Why? Because the duration of bond 2 is 10, which is exactly matching with the duration of our liability, because we want 1790 at 10. And that's why this is happening. In case of bond 1, we are failing. In case of bond 3, we are winning. But all these things are happening because we know what is going to be direction of the interest rate. Now, why this problem we are facing in immunization? So I just want to show you something. So basically what happens, there are two parts of the bond. So one is you get coupon which you reinvest, and other, when you sell it, you get the present value of the bond. Both these things move in inverse direction. So if the interest rates are increasing, if the yield is increasing, so what happens? The reinvestment gives you higher value, but bond gives you lower value. And this is the dilemma that we face. So when interest rate increases, the reinvestment coupons increase, but the bond value of the bond will decrease. Why? Because new bonds that are getting issued in market, they will be giving you better returns. So investor will be shunning these older bonds, and because they will be avoiding these bonds, so prices of these bonds will decrease. So exactly this happens in market, and this is why we face this problem of immunizing a bond portfolio. So then what do we do to take care of this? So we not only we match duration, and this is how we end up solving the problem of meeting our liability. But duration alone cannot solve all your problem. The reason is there is a graph that I think I have kept. Yeah, let me show you that first before we start this. Yeah, so this is from the textbook of Fabosi. So this is how the textbook shows that when you calculate duration here at this point, yield y star and price p star, and if the prices move by very small amount, let's say 3 basis point or 4 basis point up or down, there won't be any difference between what price change you calculate by help of duration or the actual price, because as you can see, the tangent line and the convex relationship between the yield and price is almost similar for a small changes. But for very large changes, let's say the price moves by 3% or 4%, because that's how interest rates behave at some point of time when there are huge expectation, or when there are huge inflation expectations built in market. Now in this case, as you can see, your duration will calculate your prices to be here, where the actual price will be here. In case yields are rising, your duration will calculate your prices to be here, but actual prices will be here. So there will be a gap between the actual price and the calculated price, and here also. So whether interest rate moves up or moves down, there will be mismatch between what your duration calculates your price changes to be and what the actual price changes. So to take care of that, we need to calculate the second order effect, which is what we call it the convexity. So now to solve this problem of convexity, we can also do one more thing. Is like we have the bond 1 and bond 3. We can also invest in bond 1 and bond 3 and then get the same duration of 10, which is what we wanted. And we'll see how we can do this. So let's say we invest lambda amount, or let me say I invest L. So I invest L into bond 1, which has a duration of how much? 7.67. 7.67. Okay. And plus, if I invest L amount in bond 1, then I will be investing 1 minus L into bond 2, the duration of which will be a bond, like I'm using bond 3. So the duration of bond 3 I will take as 14.64. 14.64. This should give me value equal to 10. So if this is the equation I have to solve, let me make it a little bigger so that you can see it. So yeah, so if I invest L amount in bond 1, which has a duration of 7.67, and 1 minus L, because of course, like I'm going to be having only 1000, so I'm investing part of that into the first bond, which has a duration of 7.67, and the rest fraction in the second bond 3, whose duration is 14.64, and I want the duration. If I solve this problem, so what this is very easy to solve. So what I will do is this is like very if you see this, if I just expand this, so this will be 7.67 L plus 14.64 minus 14.64 L equals 10. So which will give you a value of so if you solve it, so L will be equal to the value of 14.64 14.64 minus 10. So let me keep a bracket over here. So betterment divided by, because on the left side I have 14.64 minus 7.67. This is how this is to be calculated. We have done it in portfolio optimization also. And once I click it, it's giving me 0.665. So what it means is, if I am going to use 1000 face value, so I have to buy 665 face value, 665 rupees in bond 1. And so 1 minus L will be 1 minus this one will be 0.334 or 0.3. So exactly this is what it is given. 665.09 in bond 1 and 334.91 or like 89, whatever. So if you invest into this much amount, even with bond 1 and bond 3, you will end up with the same duration and it will solve the purpose of duration. So let's see how this happens. So so as you can see, now whatever you are seeing it here is the same thing what we have taken it from previous class. So now I'm going to calculate what will happen, whether I'm going to get the duration of 10 in case I am using bond 1 and bond 3. So what is happening is equals, I'm using this one into this one plus this one, this much into this bond, and then almost 10, I'm going to get a duration of 10 with the if I have the bond 1 and bond 3 in my portfolio in the proportion of 66.6% and 33.5%, then I'm going to end with the same duration. So we can do, rather than going for one bond, which was because many a time you cannot get a bond whose duration is exactly matching with your portfolio duration. So in that situation, you will have to tweak this, and this is what we do. So we use a combination of bonds, and then we use in that proportion where we end up with the same. The bond price and face value I'm not calculating, it is left to you, so you can do. Now let us see the situation. We are using bond 1 and bond 3 to immunize this portfolio. Now YTM is changing to 7%. YTM is changing to 7%. Now if YTM is changing to 7%, what is happening to bond 3? So the price of bond again will change. What will happen? So rate here will change as 7%. How many periods we are looking for? We are looking for 20 periods because we want to sell this bond after when there are 20 periods left. After 10 years, when we sell, the 30-year bond will become 20-year bond. And then how much payment? So payment will be minus 59 because I'm using the negative number as per convention. And then how much face value? So face value will be still 1000 left after another 20 years. And if I press enter, I get 883.47. If I invest these coupons, so I use face value or future value. So what is the rate? So coupons are going to be invested at a higher rate. So obviously the coupons will accumulate. And then how many periods? So there will be 10 periods because these coupons are going to be invested for 10 periods. And how much is the payment? So payment is going to be 59. So I use negative so that I get positive value. And then the present value is nothing because we are not paying anything to get this coupon. Already the payments have been made. So this gives you 815.170. If I sum it up, I get 1698. So I get 1925 for bond 1, 1698.64, which is the same number here as bond 3. Now I will have to multiply by the percent I have deployed in the bond. So bond 1 I have deployed this much, bond 2 I have deployed 91%, bond 3 I have deployed 1.01%. So if I multiply this into the percent of the face value bought, so I get 1831 and I get 1722. Now just see the magic because we are using the combination of bond. So what is happening? I have bought bond 1 and bond 3. So if I am going to use this 0. Yeah. So the proportion of bond I have bought is this much. So with this much, I will get this much plus this much proportion I've invested in third bond, and because third bond's price is this much, so I should be getting these 2 bonds. And if you can say this here, so I'm getting 1849.65. Why is it so slightly? Just a minute. 1849. So it should be the same. So what number I have? No. So 257. See, 257 is fine. and C251, no, 251, no. Okay, here it's wrongly multiplied. Yeah. 257 is the fraction available, and what I'm going to get, I will only receive this much of value because I've invested not much, so I'm going to receive this much of value, and then I have this much fraction in bond 3, and because in bond 3 I'm going to get this, so then I'm going to end with 1794. Okay, so as you can see, if I use bond 1 and bond 3, I'm going to end with 1794.843, and my requirement is 1790.85. So I'm exactly or like slightly, which is okay because like we are just matching duration. But using bond 1 and bond 3, we have matched the duration and our liability horizon is completely matched. So we are ending with the same amount of money what we needed, which is what bond 2 is also doing. So basically, bond 2 and bond 1 and 3 in certain combination are also doing the same good by just tweaking the duration from the bond 1's duration of 7.66 and bond third duration of 14.63. So we change their proportion in such a way that their combined duration, because duration is nothing but the linear combination of their proportion in which different bonds are invested in different proportion. So we are going to end with the same thing. Now the next question that is very important is, because we are ending with the same money, 1792 in case of bond 2 and 1794 in case of bond 1 and bond 3 when they are invested, what is the difference when we just buy either bond 2 or buy bond 1 and bond 3 in the proportion of 66.5% and 33.49%? The answer is this one. So this becomes a table which we can create by entering Excel formula, but I've just taken it as it is there in the textbook. So what happens is, as yields are changing from 0 to 15%, as you know, we can calculate the price of bond 1 because bond 1, and we can calculate the price of bond 3. And because bond portfolio is the 65% bond 1 and 35% bond 3, so this is how the prices of this bond will be. Bond 2 prices will be this, because bond 2 price, as you know, is anyway given and we can calculate with different yields. When we plot the performance of bond 2 versus the bond portfolio comprising of bond 1 and bond 3, this is what we get. This is what we get. So what is the difference? So as you can see, the dotted curve, the curve where there are dots, black dots are there, and one curve where there are no dots are there. So the curve without dot is bond 2, and the curve where there are dots are there, which is convex, is our bond portfolio. And this is the $1 million finding of the whole thing about bond portfolio management is, if you can get a convexity matched in your bond, so you are taking care of all the differences, most of the differences between the actual price, which happens when there are changes in case of the yield in market, and the way your bond behaves. So what is happening, the best thing that is happening is our portfolio is much better to take care of. As you could see here, I want to show you once again. As you can see, the actual price changes are like this. Actual price changes are like this. In real life situation, the actual price changes are like this, but our duration calculates price like this. And that's why you need to have a portfolio which is more duration matched. And that is exactly what this portfolio is doing. So this is how we match the convexity. So the better property of a bond or a portfolio is to also have a better convexity. So that's what we are going to now see. So again, we get back to the same example of the bond, but here what we are going to do, we are going to see in case of 4 bonds. I will tell you later why I am using 4 bonds. Earlier we did with 3 bonds, where bond 2 was having a duration of 10 and it was exactly matching our liability duration of 10, and so it was immunizing our portfolio. Here what is happening, I'm using 4 bonds and their coupon rates are different. So in case of bond 1, the coupon is 4.5%. Bond 2 coupon is 6.99%, which was the case before. And bond 3 coupon is 3.5%. Bond 4 coupon is 11%. So bond 4 is very different from the previous bonds, and also bond 3 and also bond 1. Only bond 2 is exactly the same, because 6.99 is the coupon, maturity is 15, face values, and then as you can see, its duration is also 10, which is like, so bond 2 is like, if we have this bond 2, then we are fully duration matched. Now, so I'm not going to calculate the bond price and face value, because this is like, we have done it umpteen number of times previously. So you can try it by just using the PV value function for here, because this maturity is for 10 years. So you'll have to use 10 years. And then like face value, how much you'll use is depending on how much price you are paying compared to 1,000 rupees face value. So so the duration again, like if we can calculate duration, so we will calculate day duration. That is better formula for us. So in case of day duration, against what we need is the number of period. So here you are going to have a 10, because this is a 10-year bond. And the next is coupon percent. So coupon percent is 11%, which is 0.11, which is fine. And the next is YTM. So I'm taking YTM as 6%. And then, because this is going to be yearly bond, there is no fractional time period in which we are going to receive coupon. So this is giving me duration. Now for convexity, how do we calculate convexity? Because we are going to manage our portfolio with by not just duration matching, by also matching convexity. So convexity is nothing but the second order derivatives of bond price with respect to interest rate. You might have been taught this in your fixed income class, but I'm just repeating. The convexity is nothing but the second order derivative of the bond price with respect to interest rate. So if you go and calculate, it's going to be a very long, like if you have a relationship between bond price and the coupon and the time period and all those things are given, then you can calculate second derivatives, but that will take you a very longer time. So what we do is we calculate a term called second duration. So we calculate second duration. So what we need for second duration, here I have written a formula. So second duration, you need the same thing as number of periods, coupon percentage, YTM, and then you have to deflate it by price upon the face value. So what I'm going to use here is the number of period. So let's. So number of period is 10. Okay. Coupon percent is 11. And YTM is 6%. And I have to divide this by the face value of the bond, the price of the bond, by its face value, which is 1,000. And then I am done. If I press hit, I get the 67.60. So this is the convexity, and this is the duration. So as you can see, if you're just matching duration, so we were using this. Now if we start matching the convexity, we have to use this also. We'll see how this is this can be done. So now see this magic. When you use duration, the convexity, and then you use immunization techniques, so your portfolio is almost fully immunized, because you need 1790.85. We started with this problem. We had $1,000 in the beginning. We had the interest rate of 6%, and we invested this for next 10 years. So we wanted to end with 1790. So almost in all the cases, if we are taking care of the second order derivatives in this case, which is what we call convexity, So our portfolio is behaving much more stable than one where there is no uh, convexity matching. So this is behaving much better. And of course, this graph is coming from here because this is taken from this data table. So now the next question that is important is, how do we calculate a bond portfolio where we can exactly meet the duration on convexity so that they are in right proportion, and then we are done with our immunization problem. Now this is the most important part of our the best part of the whole discussion up till now. Is in reality what happens is normally a bond portfolio manager has around 100 to 200 bonds in his portfolio, and because the expectations are changing every now and then, so he need to alter his portfolio duration. And if it doesn't enter, if the interest rates increase, he is going to lose severely. If interest rates decrease, he will gain somewhat, because as you know, the longer duration, the longer will be price changes, and when interest rates decrease, price changes will be higher, and that's why the longer duration is beneficial. But when interest rates are going to go up, a bond portfolio manager is better advised to sell longer duration bonds and get into shorter duration. And this is what is done by the bond portfolio manager in case of either a mutual fund manager or a hedge fund manager. So what we need is, like we have 4 bonds: bond 1, bond 2, bond 3, and bond 4. So bond 2 anyway is immunizing our portfolio exactly because we have taken it a textbook example. So somehow its duration is 10, and so it's matching. So how can we select bond 1, bond 3, and bond 4, where their duration as well as their convexity are selected in such a way, and their proportions are selected in such a way that they are able to immunize our portfolio in a much better way. So the first condition that we need is x1 plus x3 plus x4 should be equal to 1. Why? Because as you know, the first premise on which we started our discussion today is we have only $1,000 and we want to end with $1790.85. And that's why the maximum amount that we can invest is $1,000. So if we invest 500 in bond 1 and 300 in bond 2, we can only invest next 200 in bond 3. So the proportion will be 0.5, 0.3, and 0.2. And depending on like how much we are investing in bond 1, we'll be left with less in bond 2, and then whatever is finally left over after allocating to bond 3, then that will be invested in bond 4. So this formula will work: x1 plus x3 plus x4 equals 1. The next condition that is required is the duration should also be matched. So then we write this equation, and which is x1 into d1, because we are selecting x1 as bond 1 and its portfolio duration is d1, plus x3 is the amount we are putting in bond 3 and the duration of the bond 3 is d3, and then we are putting x4 in bond 4. So x4 into bond 4 duration should be equal to the duration of bond 2, because bond 2 duration is 10. This is what we have seen. And we also want to make use of these 3 different bonds: bond 1, bond 3, and bond 4, and to make their duration equal to bond 2. Now, one question that again you should be asking me or should be asking yourself: if we already have bond 2, why are we doing this maths for bond 1, bond 3, and bond 4 to solve for this duration and convexity issue? There are many reasons, but the most important reason is, one, many a time you will never get a bond in market whose duration exactly matches the duration that you want to match. So if your liability is 10 years, probably you'll get a bond with 10.5 duration or 9.5. Now you'll have to select some other bond where you can mix and then have a duration of 10. The other thing is, as I told you before, a portfolio of bonds with different duration is going to be more stable whenever there are issues that you're going to face in terms of immunizing a portfolio. So the second requirement is the proportionate combination of the bond and its duration should equal to duration of bond 2. And the third thing that is required, that's very important, is the convexity of bond 1 plus convexity of bond 3 plus convexity of bond 4 in the proportion in which they are invested should be exactly equal to the convexity of bond 2. So how that is possible? So x1 into d1 square plus x3 into d3 square, which is convexity of bond 3, and plus x4 into convexity of bond 4 should be equal to convexity of bond 2. So now when we have the d3 equation, equation 1, x1 plus x3 plus x4 1, x1 d1 plus x3 d3 plus x4 d4 equals d2, and x1 into d1 square plus x3 into d3 square plus x4 into d4 square equals d2 square. When you have the three equations, so basically what you have is this matrix, which is 1 1 1 d1 d3 d4 d1 square d3 square d4 square, and second matrix brackets x1 x3 x4 equals 1 d2 d3 square. Now, as you know, if you have a matrix like this can easily be solved, because this is what you did in case of S into Z equals ER minus C. When you are selecting a portfolio, when you are selecting the portfolio Z, which would exactly optimize your the mean and variance. So that was what? So the one variance covariance matrix, and the last one was the expected return, and this is very similar to that. So how do we get the x1, x3, and x4? So x1, x3, x4 is nothing but the inverse of the matrix first, which is 1 1 1 d1 d3 d4 d1 square d3 square d4 square, and this multiplied with 1 d2 and d square. So once you do this, we'll get to know how much x1, x3, and x4 is required. So let's come to the three bonds that we have used here. So the three bonds that we have used, as you can see, is bond 1, bond 3, and bond 4. Duration is 12.89, 10.84, and 7.05. Convexity is 229, 148, and 67.59. Exactly this I am taking it here. So exactly the same numbers I have taken. This x1, x2, x3, x4, duration 1, duration 3, duration 4, convexity 1, convexity 3, convexity 4, and that should be equal to the 1, the duration of bond 2, and the convexity of bond 2. So how do we calculate x1, x3 first? So as you know, I select the three array. You have already done it in case of mean variance optimization of calculating the best portfolio, the optimal portfolio. So I'll write it here over here, the matrix multiplication, and then matrix inverse, because I'm going to use inverse of the first matrix. So I use this matrix. I close the bracket and use comma because it's going to be multiplied by this. And then I close the bracket and I use Control Shift plus Enter because I'm using array. So what I'm going to end with is 0.56 minus 0.56 of bond x1, 1.64 of bond 3, and minus 0.08 of bond x4. So what is happening is, here I have to short to bond x1 and x4. Now let's go back to x1 and x4 once again. You'll understand why you have to short. So in case of bond 1, its duration is 12. Bond 4 duration is 7. And bond 3 duration is 10. So bond 3 duration is somewhat very closer to this duration. So bond 3 is in positive combination, and bond 4 and bond 1 is being shorted. And again, if you see the duration of bond, the convexity of bond 2 is 136, which is where this is closer, or bond 3. So bond 3 is like matching almost. So that's why we are shorting bond 1 and bond 4, so that net they can give you the same effect. So with this into the situation, we have to short 56% of bond x1, 8% of bond x4 we have to short, and we have to buy 164% of bond x3. Now the most important thing, coming back to business, that if we have calculated bond and calculated duration and calculated the convexity, so how are we going to check for how much is the price going to change, and how much is the convexity, how much is the price going to change in case there is change in the yield of a bond? So duration effect, as you know, is duration into change in yield, or you can better write minus duration, because normally durations are given in absolute number, because it is implied that if interest rates move in the negative direction, then prices will behave in positive, and vice versa. So normally this relationship is written like this. So minus duration into change in yield. Yield should be in percentage. So why? Oh, I've used minus. Okay, this. Okay, yeah. If I write like this, oh no. Oh, my God. Just a minute. So minus duration into delta, change in y, delta. So if I insert here some symbol, oh, so let me write y. So I take, so it's taking as formula. So just it's taking as formula, which should be avoided. So just ignore it. The second convexity effect is half into convexity into change in yield square. So these are the two things that we need to take care of whenever you are trying to solve the problem of bond with the help of duration and with the help of convexity. Now, this thing might sound little offbeat to you, that why here in case of here we can write minus duration into delta y, delta y. You know why this is happening is because I'm using window 11, which by default is assuming that I'm entering some formula. So I also need to get familiar with Windows 11. This is a very new Office suite that I've just installed on my new PC. So nothing to worry, but take this formula, it's minus duration into delta y. So if I go back, probably I can change it. So, and convexity effect is half into convexity into change in delta y square. Now the question that you can ask is why half here, but the full amount here in, the answer again is the same. If we go back previously where we saw this, see what is happening here is, in one case the prices rise more, in the other case prices rise less. So what happened, we don't know in which direction the price is going to be, so we use the average of these two, so that what happens, we are very close to the actual price, and that's the reason why we are using it here, the half of the convexity into change in yield square. So this is how we do. Now to understand this, let's see the example here. So what we are going to do, we have a 25-year 6% bond, which is selling at 90% yield. So just remember, if a 25-year bond, a 6% bond is selling at 9% yield, this must be a discount bond, because only then it's possible to have a 9% yield. The modified duration for this bond is 10.62. Now, for a change, the example is using modified duration, and we have always been talking about Macaulay duration, but nothing to worry whether you use Macaulay or modified duration. It's the changes are going to be not very significant. We have been using Macaulay, but here the example is giving modified. That's fine, because both are duration. And the convexity measure is 180.92. Now the question is telling you, if the required yield increases by 200 basis point from 9% to 2%. So again, like what happened, all of a sudden there is inflation numbers announced by the Federal Reserve or the Reserve Bank of India, and the yield rises from 9% to 11%. What will be the approximate percent change in the price of the bond? So this is very simple. You must be knowing this, but we'll calculate this. So this is equal to minus, I will calculate the duration effect. Duration is 10.62%. So 10.62 into, now how much is the bond changing 200 basis point? It means it's changing by 2%. So 2% means 0.02. So this is duration effect. Okay. And what is convexity effect? So convexity effect is half, means 0.5, then into, what is the convexity? So 182.92 into the yield square. So yield is changing by 2%, which is 0.02 into 0.02. And if I do it, how much is the convexity effect having? The convexity effect is having 3.65% change, and the duration effect is having 21.2% change. If I sum them up, which is what I can do, go to home and auto sum these two numbers. So I'm getting 17.58%, which is the same as textbook answer. So, so effectively what is happening in case of this bond is the price of this bond, this particular bond, will change around 17.58% because of this particular issue, because the interest rates are going to increase by 200 basis point. So the uh, price is going to change by 17.5%. Now I want to test the intelligence of the class, because if I don't do, then you will never understand this. So I created a puzzle here. So now the same question I've changed slightly. Now, if the bond is the same and everything is the same, but what will happen if there is the yield decreases by 200 basis point? Remember here, the yield is going to decrease here, and in the previous case the yield was increasing, and so price decrease here. So you have to tell me exactly how much will be change in price, and in which direction. So you have to just calculate and then get back to me. So Sharanya, Jaideep, and Sanika, Gaurav, like you need to do this, because if you don't do this, you will never understand this. So I will wait for 5 minutes, and I will see your response, and then I will tell you where you have committed mistake in case you have, and if you have done it right, then perfectly alright. Then we will move to the next. Uh, so okay. So I'll wait for 5 minutes before you guys finish this and do it. You can see it as you have seen it. Here I have written the formula also. If you press here, so you can see duration into delta, minus duration into delta, duration effect, half into convexity into duration square, convexity into the yield square. Change in yield square is the convexity. So you have to calculate these two effects and then tell us that what is going to happen to this bond, and then we'll see. So are you ready? Hello, Sharanya, are you there? Jaideep, Gaurav, Sanika, are you there? You guys don't seem to be around. Sharanya, my God, if you guys don't do this before me, how will I understand that whether you can do this? Yeah, Saranya, others are also not responding. That's what I'm saying. That others are not responding, and that's why I do. So, can you solve this problem which I gave, or should I like move to the other section? I've given a very small problem because I want you to grasp this before you do anything else. Because unless you understand this problem as to how duration and convexity effect plays in case of bond, you are not going to understand these things. Okay, okay. So I will move to the next thing. So I'm letting it be here. I'm not solving this because this is important. So you guys have to solve this and then get back to me. Now, uh, you remember when we were talking about immunization problem, we talked about term structure of the bond or term structure of the interest rate. Why? Because what happens is in real life situation, the term structure of the interest rate keep changing in reality. Why? Because time changes. So, for example, just say Financial Times reported this on like this on 29th April. This is the situation. So what happened at the end of December? The blue graph was showing that the long-term yield was higher than the short-term rates, and term structure was upward sloping. Fast forward to April, because when inflation expectations are built, the term structures are almost flat. Almost all the, whether 2 years, 5 years, 7 years, 10 years, or 30 years, the tenor for which bonds are actually available in US market, they are all close to 3%, means the term structure flat. Why? Because no one wants to take any chance. People are so afraid of inflation. So the term structures have become all upward slope, almost flat. Now, why this is important? Because we price the longer tenor bond on the basis of the term structure. Because if you don't know the term structure, how do you discount it? Because you need different discount period for different cash flow. Because cash flow you'll be receiving after 2 years, 3 years, 4 years, 5 years, 10 years, 15, 20, or 30 years. And that's why you need different term structure. So getting to know the term structure of a bond is very, very important. Very, very important in case of the fixed income portfolio management. So what we are going to do here is we are going to take 15 bonds. So we have this 15 bonds, bond 1 to bond 15, and their prices are given here. So prices are always given. You might say where from these prices are coming. So if you go to NSE website or RBI website, you can always get to see the price of the bond and their tenor. So these are bond for maturity 1 to 15 years. Now coupons are also visible because the moment you see coupons, let me see if I can show you NSE bond. So if I can show you, so let me see if I can show you where we can get this India.com. So let me share something with you. So as you can see, uh, for- as you can see, I'm showing you here different bonds here. All these are corporate bonds, and some bonds are the government bonds also. For example, or like the public sector bonds also. The National Highway Authority of India, this is regular bond. The coupon rate is 7.6%, face value is 1000, but last traded price is 1160. You know why? Because expectations have changed from the time it was issued. They are demanding higher interest rate, and how much is being traded, so value, and what is the credit rating. So all details you get on about the bond, their tenor, and all that. So if I click on this particular thing, I'll get a lot of information that what is this series. So you know that the settlement is maturity is 2026, settlement is happening today. So all the things you get here. So that's what. So this is how you get prices of bond and their tenor and other things. So yeah. So let me again take back to the yeah. Yeah. So the coupon rates are given and the prices are given. Now, what we are interested in knowing is what is the term structure of the interest rates. Fortunately, see, the funny thing here is you are getting bond for all tenor, like 1 year, 2 year, 3 year, for up till 15 years. If this is the real situation in market, then you are in heaven. Why? Because you can see what exactly you want to see, but this is not really the situation. Why? As I showed to you, in terms of, in case of Financial Times, one click of the term structure of the interest rate. Normally, you have 2 years, 5 years, 10 years, 20 years, and 30 years term structure. And from there, you either bootstrap or like you get to know how the term structure is going to be, interest rates are going to be behaving for the in between periods. So, but here, like assuming that they are given, so coupon rates are given here. Now, if I have to calculate term structure, I need to calculate their YTM, because term structure is nothing but an yield, which is like what if you hold it till maturity. So what I have done it here is, for the bond is 96.60. So here I have written 96.60 minus. Why? Because I am paying it. Bond price is 93.7. So I'm writing it minus 93.7. Bond price is 119.73. So I'm writing minus 190.73. So these are the prices at time 0, which is I am paying. Now, if the bond is of 1 year, so next 1 year I will get 102 and I won't get any money thereafter. If the bond is of 2 years duration, first year I will get 2.5, second year I will get 102.5. Why? Because the coupon plus interest will be returned. If the bond is for 3 years, I will get coupon for 3 years, and in third year I will also get 100 rupees return, and then I will get 103 rupees. So this is how I'm going to get in case of all those bonds. So even 15-year bond, I'm going to get 9 rupees or $9 for next 14 years, and on the 15th year I'm going to get 109. So this is how I have created metrics for this term. Now, if I have to calculate YTM, so like how do I calculate YTM? So I write so as you can see, it is asking me settlement maturity rate and all that. So it's going to create the same problem, which, so I will have to write dates and all that. So it's going to take longer. So what I will do, I will use the formula called IRR. Okay. And then the IRR will only require me to insert all the cash flows. So I'll select all the cash flows up till year 15, and that's it. And I'm not going to guess anything, because let the computer guess, and I'm pressing enter. It's giving 5.59%. Now, because I've used for the entire year, so if I just drag down, so I'm going to get the YTM for all these 10 bonds or the 15 bonds, which is like the textbook answer is matching with the YTM that I have calculated. Now, what is happening? If I plot these YTMs over here, as you can see, so I'm getting a graph like this. And this is the graph that is what is reported in financial newspaper or like in any newspaper or by the electronic media. So they keep saying that yield curve is upward sloping, yield curve is flattening, yield curve is inverting, and things like that. So here what is happening is actually here yield curve is upward sloping. So it's a sloping, and this is what is visible over here. So this is how you calculate the term structure of in. But as I told you, the challenge is going to be you may not have all the bonds for all the duration for which you want to calculate the term structure. So in that case, you may have to use your sophisticated the method of inserting the yield, or like doing certain other techniques like Nelson Sagel methods. So then you can put in all those yields and then calculate the term structure of the bond. Now, so this is how we can calculate the YTM and then the term structure of the bond. Now, there is another way to do this, because if we have Excel, doing this kind of iteration will require inserting too much of value. So what we do is we write a relationship like this. So for example, in case of bond 1, okay, here we are going to use something called discount factor. So because if the bond is for 1 year, so discount factor will be used as D1. If the bond is 2 years, so discount factor will be D2. If the bond is 3 years, discount factor will be D3, and like that. So if we keep doing this, so 96.6 is the price of the bond that we are paying for the bond of 1 year, and we are going to get 102 after 1 year. So effective, so it means there must be some discounting factor D1 in operation. So 96.6 should be equal to 102 into D1. For bond 2, means bond of 2 years, the price is 93.71. So that should be equal to 2.5 into discount factor for year 1 and plus 100 and 2.5 into discount factor of year 3. If I go to bond 3, so what is the price of bond 3? So bond 3 is 91.56. So I will write here 91.56 equals, so how much is the coupon I'm getting? So in case of bond 3, I'm getting 3. So 3 B1. Just a minute, let me switch on the light. I can't see. Yeah. So D1 plus then 3 D2 plus 103 D3. This should be the situation. Effectively, what is happening? We will get into an equation like this, where the price of a bond is equal to all the cash flow discounted by a discounting factor. So rather than using the IRR, we are using a discounting factor, which is what we were taught when there was no computers. Now, if we keep doing in eternity, because there are 15 years bonds, so there will be 15 discounting factors. So effectively, our price is going to be the summation of all the coupons into discounting, which is very simple. Coupon, but time equals t is 0 to n, and coupon times the discounting factors. If we use metrics, then what we are going to have is the coupon 1, coupon 2, coupon 3, 4, 5, and n1, n2 up till whatever time we are going to go get coupon and cash flow, or cash flow is better term, because we are going to get cash flow multiplied by the discounting factor, we are going to get prices. So again, by seeing this, you must have realized that this is very similar to what we did before for in case of the mean variance optimization. So if I take out D1, D2, D3 left, so I will have the equation where there will be matrix of all the cash flows in inverse proportion multiplied by the price. So the discount factor then will be equal to the inverse of this, all the cash flows into the prices. So coming to this, if I want to calculate this discount factor, so I will select all the discount factors, and then I write it here, and I have to matrix multiply. So I will use matrix multiplication, and then inverse. So inverse, and then in inverse I'm going to use this. I'm going to use this 15 matrix, and then I'm multiplying this by these terms where the prices, because the next is the prices. But as you can see, the prices are in negative, so I have to just enter negative and then select prices, because if I keep this, then there will be confusion. So I take the negative of these prices, and then I close bracket, and then I hit enter. So I've got all the discount factors. Now that I've got this discount factor, so my job has become very easy. So now if I have to price any bond for any duration, I have the discount factor for all these terms, and then I can just use all the cash flow, multiply this cash flow with the discount factor. Another advantage of this discount factor is, from the discount factor, I can exactly get to know the term structure, the interest rate prevailing at that point of time, and we'll show you when we use it in the next one. I want to just stop here, because I understand you might have been bombarded with some very tough concepts up till now. So this is how we calculate the discount factors. And then if we want to calculate prices, so we can calculate price of any bond if we want. I can do it right now, but my sense is probably you are not going to take it very easily, because it may be a little tough for you at this moment of time. So I will just stop here. However, one thing I can tell you is, if you have the discount factor, so what you have got is D1, D2, and DN. So you have got these things. So if you want to know price of a bond, and if you have the discount factors, so all the cash flows, if you do, then you can easily get to know the prices of those bonds. So for example, if like we have a 5-year bond, where like the same bond, this calculation we can do. I leave it for the class. So this 5-year here, this is a 5-year bond, which is paying you how much? Yeah, four rupees or $4 every year, and finally is 104. If I have to price this, how I can price using this discount factor? I can easily do it with the same matrix. So I will create a matrix of all the cash flows, and then D1, D2, D3 up till D5, and then I will get the prices for all these 5 years. So this is how it can be done. So I'm stopping here, and hoping that you could understand whatever I was saying, and this I expect you to solve these two things: duration effect and convexity effect, and the net effect of the change in the yield by 200 basis point, and then send me answer on my wherever you want, like email or wherever, and then I will get back to you in the next class whenever I am there. So with this, I wind up, and we break. Okay. So Sharanya, is it okay?